There we go. We're recording. We've got whiteboard stuff. What it is. The screen's too small. I'm used to like a 7-foot screen. I like a screen the size of a piece of plywood. That's the only way I can operate. All right, cool. So thinking about our regression models, these are really nice. If we've got a number of things that we're thinking may hold unique associations with some relevant outcome, right? What we're doing, we're saying, hey, does this variable predict some outcome above and beyond sort of this other stuff, right? Like, does this measure, Mesa's got to measure something that she's predicting will account for some variability in inattentiveness in kids with ADHD? Is this going to go above and beyond and sort of incrementally predict something above if we account for some of this other stuff? Really, really nice way to go through and sort of test some specific theory-driven hypotheses. But what we find is that, like, there's only so many studies I can run through before I sort of demonstrate a unique association between X and Y before things start to become kind of boring, right? And if lots and lots and lots and lots and lots of people have shown that measure X relates to hyperactivity above and beyond everything else in the model, it starts to become not terribly interesting, right? We also find that these coefficients are pretty limited in what they say about the nature of the relation between X and Y. We say X and Y are related to one another, but just that general association doesn't give us a whole lot of insight into sort of what the inner workings of the phenomena that we might be trying to target here, right? And so once we've gone through and we've got research that says, hey, yeah, you know what? X and Y tend to be pretty consistently associated, even when we're accounting for other things. One step forward in thinking about, like, what's the next question? How do I go through and build on this literature? Is start thinking about the conditions under which that association holds. Okay. My question here is, I see that X is related to Y. Is X related to Y for always and forever in the same way across all situations and circumstances and population of people? Probably not, right? I don't know that I can think of some association that's going to remain consistent across all contexts and things along those lines. And if we start to go through and ask those questions, it starts to tell us information. We got to start to get information on boundary, sort of on boundaries, like how, sort of who does this association or where does this get stronger, or where does this get weaker, right? We can't really test this in our standard regression model that we presented up to this point. And so what we've got now is we're switching over into a moderation, right? Okay. Moderation is going to be defined as a process where some external variable, some third variable here, changes the nature of the association between X and Y. Okay. We've established that X and Y are related to one another. We know that that's, if I were to try and publish a paper that says X is related to Y, it's not going to get published because no one cares, because we already know that, right? But what I might start to think about is, under what conditions are there things that start to change the nature of this association between X and Y? Okay. And so under this definition, a moderator is going to be any variable that starts to change the strength or the direction of the relation between some predictor and some outcome. Okay. And what we do is we go through, oftentimes you'll see this diagrammed in this way. Here we've got a relation between X, we've got a relation between Y. I'd like to think about this a lot of times as your base relation. Oftentimes your base relation is something that's going to be sort of known in the literature, right? We already kind of understand that these two things, we expect these two things to be related to one another. What's the moderator? What's the thing that from a theory-based standpoint is expected to change either the strength or the direction of that association? Okay. So let's say here, as an example of a hypothesis, the impact of stress on physical health is going to depend on the degree of social support available to the person. Okay. In this hypothesis, what might be a reasonable way to think about, like, how might social support impact the association of stress and physical health? What do you think, Danielle?
I think it would alleviate some of the impact of stress on physical health.
Okay, cool. So what's that going to do to the association between stress and health? Is that going to make it stronger or weaker? Weaker, perfect, right? So yeah, we see that stress is related to physical health, but if I got lots of supports, that's not as strong of a relationship. If I have no one in my life, the relation between stress and physical health is going to be much, much stronger, right? So we've got a third variable that's going through. We already know that stress impacts physical health. Lots and lots of data on that. But under what circumstances? Are there things that start to change the strength of that association? Okay. I would say the relation between psychological distress and problematic substance use differs across men and women, right? Here we've got a population question. We're saying that for men and for women, we get a different association between distress and problematic substance use. It looks differently, that this association looks different depending on who we're talking about, right? And so again, when we're thinking about these moderation analyses, we're looking at the conditions under which some association is strengthened or weakened, or in sort of extreme cases, that association might completely change. All right. And again, I really like this way of thinking about moderation is like under what circumstances can we find situations where these two things aren't related or related in the opposite direction? Are they the same for this group as something else? This is just a really, really rich area for just generating hypotheses. And if you've got data papers on the types of things that start to inform theory, yeah, this theory works. These things are related to one another unless we start to change some stuff around. If we, under these conditions, these things are actually not as related, or they're related much more strongly than what we see maybe sort of overall. Overall regression, we can say, are these things related for everybody in the sample or whoever we've sampled, whatever population we've sampled from? We start to get more nuance here. And what we would say in this situation, if we do find a moderated relation, we would say that the relation between X and Y is conditioned on M. Okay. Condition just means depends. Okay. Now, if I find that the relation between X and Y is conditioned on M, can I then just talk very straightforwardly about the relation between X and Y? Nope, because I don't know what the relation between X and Y is unless I know what M is. If I know what M is, then I can tell you what the relation is likely to be. But absent this information, I have no way of sort of making specific communication about stuff. Where have we heard this or talked about this before? Okay. This type of process. Yeah, so this idea of a conditioned association, or where we have some variable that changes the nature or the relation or the difference between two other variables. Haley? Yeah, our ANOVA stuff, right? Anytime we're going through and we're looking at a factorial and interaction effect, we're talking about moderation. For the history of psychology, right? That should have based in our experimental roots. A lot of this was based on factorial ANOVAs, right? If we wanted to look at interactions, we had to go through and look at it in an ANOVA situation. But the problem is, there's a lot of things that we're looking at, sort of conditioned relations they're not categorical things, they're not groups, they're continuous types of things. For a long time, till like the 80s, having a hard time putting together a framework for how to go through and do this. But this has now become super, super commonplace. It's kind of a bread and butter analysis within the context of psychological science. Taking this out of just our factorial ANOVA, where we're looking at interactions between grouping variables, and taking this over into some continuous variable models. Okay, so all the stuff we did last semester in terms of factorial ANOVA, moderation, it's all the same thing. Conceptually, it's identical. There's no difference. There's nothing that we're going to talk about in these models that we couldn't apply to a factorial design. I can run a factorial ANOVA in regression. It's good because our ANOVAs are just a special case of regression. So, generally, historically, we tend to look at these interaction effects, as I've talked about before, within the context of an ANOVA model, right? We're saying, look, we're looking at the interaction. We're interested across the white and black communities and men and women looking at sort of impacts on social bonding, right? So maybe we go through and collect these data as grouping variables, right? We've got a sample from residents within the Black community, residents within sort of white community, go through, have people identify as men, women, and then go through and look at impacts on social bonding, because we have maybe hypotheses about acculturation and sort of in terms of gender acculturation and sort of culture on how people relate to other people or something, right? So we're good. We're like, okay, we can go through and do this. We can run this in a 2x2 ANOVA, right? But this model starts to get tricky if I'm starting to sort of hypothesize interactions between that involve some sort of continuous variable. Okay, let's say I want to look at the interaction of sex and SES on institutional salary. I'm saying that maybe sort of my SES determines like sort of where I'm at in terms of how much money I'm making in the future, but I think that maybe differs for men and women, right? Now all of a sudden though, I've got SES that's hard to conceptualize that well as a dichotomous variable. I could say, oh, people with high SES and low SES, right? That's an artificial dichotomization, right? This is a continuous variable. Now I can go through and I can chop that in half and just put people in groups, right? And then look at things, but you all read those papers on the cost of dichotomization. What happens when we go through and dichotomize those continuous variables, right? Technically, or historically, what people have done is use things like median splits to dichotomize these continuous variables, right? We're saying, all right, like what we've done, we've got a continuous variable, but what I want to do is I want to stuff that into an ANOVA model. So I'm just going to look at the median, 50th percentile. Anybody above, you're high. Anybody below, you're not, right? Cool, I've dichotomized this. I can throw this into my ANOVA model. Problem is we lose power, possible bias effects, lots of bad stuff statistically that can come from this. If I go through and I run this in a regression though, what we can do is we can start to look at our interaction effects with any combination of continuous and categorical variables. We have to code those categorical variables correctly. Again, because I can't have a multi-categorical, I can't enter a multi-categorical variable directly into a regression model. Okay, I can't have 1, 2, 3, 4. I can recode that as a series of dummy codes or a series of contrast codes and get those in. But remember, for regression, it has to be continuous or dichotomous predictors. Okay, but we can go through and code those, so we can put any combination of these in to start doing the same thing that we would have done, get the same answer, the same question that we would have tried to answer with our ANOVA model. We're just doing it in a better, more statistically sound way. What we're doing when we're including those continuous and retaining those predictors as continuous, we're keeping all information across the whole range as opposed to dichotomizing it, right? So I'm saying that if I'm someone right at the if I dichotomize this median split, basically what my model is saying is that everybody that just tipped over the 50th percentile of SES is functionally equivalent to Steve Jobs, Jeff Bezos, anybody else who's at the sort of crazy high end of this thing. They're all the same. They're all part of the same group. That's clearly not true. We're also saying that people who are just right under the median income is exactly the same thing as people living in severe poverty and sort of very, very low SES and underprivileged communities. That's probably also not a reasonable assumption, right? But if we just leave this as continuous and we think about this as a continuous indicator, now we can look at the association between, or essentially here we can look at this as sex differences in institutional salary across the range of SES, right? A lot more information available to us here, okay? So people understanding sort of the ideas or the concept of what we're trying to do with these moderation models. Questions, because again, as we're going through this stuff, I can't emphasize this enough. Really, really critical that you understand at a conceptual level what's going on. These are complicated models. These are models I continue to screw up, but it's fine because I know what I'm doing and what they're supposed to say. So I can generally catch my mistakes after I've made them and then have to spend the review the past couple hours of work I've already done. The trials and tribulations that you all experience in problem sets are just get used to those because you'll continue that will continue to happen anytime you're doing research. It's just part of the thing, right? But what we hope is that you're just catching those mistakes, recognizing things that are like, oh, hey, if this model is working the way that I expect it to, then this thing can't exist. This thing did exist, so the model's got to be backwards somewhere, right? So really, as we're walking through this with the math, with everything, if you try and approach this with like, okay, these are the steps that I walk through to do this, it's going to be a miserable journey because you're going to be really confused and backwards. Okay, so just really focus on sort of understanding conceptually what's happening with this. So the example that we're going to sort of focus on here is looking at the impact of opioid medications and physical pain on role functioning here, right? So we've got again, this is data from sort of my graduate program. So we've got pain, opiate use, we got a measure of PTSD, and then we have a role functioning variable here that's going to be our outcome. Okay? And our questions are, do opiate medications influence the impact of physical pain on role functioning in survivors of serious motor vehicle trauma? Okay. Within this context, Gabe, what is my base relation for this first question? Conceptually, at least.
I actually have no idea what you're.
What's my base association, and then what am I implying is my moderator here for the first part?
Well, your moderator is opioid medications.
Yeah. Okay. And so what's my base relation?
Physical pain.
What's that?
Is it physical pain?
Physical pain with
Role function.
yeah. Okay. My base association. Because again, we're looking at changes in associations, right? So I'm asking whether or not lots of research, I know the physical pain is going to impact moral functioning. If I try and publish a paper that says, hey, people are in intense physical pain, they don't function so well, it's not going to get published, right? But my question is, do opiate medications help? Does this change this, right? If opiate medications are impacting the relation between physical pain and role functioning, what should happen for people who are using opiates? Danielle?
If it has an influence
Yeah.
on that, it should be good.
Right? What should it do to that association?
Weaken it.
Yeah, right? If these things are working the way, we should see less of a connection between pain and role functioning versus people who aren't, right? Second thing, does pain severity change the relationship between PTSD and role functioning following motor vehicle accidents? Olivia, what's our base relation and our moderator here?
Pain severity moderates the relationship between PTSD and role function.
Yeah, pain moderating the relationship between PTSD and role functioning. Again, PTSD, folks with PTSD is PTSD severity increases, functioning decreases, right? Well, if things work out the way they should, then yeah, that's something we should expect. What does pain severity do to this, right? Now, starts to become an interesting question. Does this strengthen that relationship? Does that make that a lot stronger? Or does it completely swamp it out? So now we don't actually see a relation because my level of PTSD doesn't matter because I'm just in intense pain and my functioning has kind of hit a floor effect, right? So again, as we'll go through, same thing the way we talked about these last semester in our factorial designs. Mathematically, your predictor and your moderator are interchangeable. It doesn't matter, right? But what starts to become important here and thinking about, like, once I do find this interaction, how do I go through and talk about it? How do I go through and probe it? A lot of this is going to be based on how you're conceptualizing the problem. Okay. So, first thing we're going to talk about that we haven't yet introduced is a concept known as centering. Who here is familiar with centering? Has ever sort of worked with centering? Johnny's okay. So we got some people. Johnny, can you tell me what am I doing with centering? Why might I center a variable? No, Lindsay, you wanna help out?
Yeah, to see how close it is to the average within the whole sample.
Okay, so we're kind of doing some of that stuff. Kate, you wanna add in?
It's a bit more like interpretable.
Yeah, primarily with OLS regression, it's just a straight function of interpretation, okay? Remember this. Zero has a very, very special place in all of our regression models, okay? Anytime I go through and I look at an individual coefficient, that individual coefficient is telling me the relation, expected association of X on Y when everything else is held constant at zero, okay? When we're saying we're controlling for things, it means we're just holding everything else constant at zero. Now, sometimes zero means something on our scale, sometimes zero doesn't. But I'm looking at the association between height, weight with risk for diabetes or something, yeah, right? Does holding height constant at zero mean anything? No. Does holding weight constant at zero mean anything? No, right? They're nonsensical values. But statistically, that's what's going on. Anytime we go through and interpret a regression coefficient, it's very literally telling you the relation between X and Y when everything else is held constant at zero. So zero starts to become important for interpretive purposes and knowing what that 0 point represents, right? Because it's going to start to make a difference in terms of how we're interpreting specific coefficients and effects. Yeah.
Yeah, a little bit of a silly question, but is this something that people do with dichotomous variables too? Like,
No, that's not a silly question. That's a very good question. Hold on to that and we'll talk about that in a bit. Okay. So centering, easy peasy. All we're doing by centering is we're just subtracting each score in our sample by the sample mean. Okay. So if I take everybody's score and I find the mean of the entire set, and I just create a new variable that's my center variable and subtract everything from the mean, right? The new mean of my variable is now 0. And so now 0 represents not the absence of whatever I'm looking at. 0 now represents the mean for that variable. Okay. This is different than standardization, like sort of creating like a z-score, because my standard deviation doesn't change. My mean changes. Does my variability change? Nope. Does the shape of my distribution change? Nope. I'm just changing things from like inches to feet to miles to anything else, right? I'm just changing the numbers and shifting things around, okay? All we're doing is we're subtracting everything in every value in the set by a constant, and it's going to go through, make my new score equal, my mean score equal to 0. And so anything above the mean is going to be positive. Everything below the mean is going to be negative, okay? So again, here's my distribution, right? I've got a mean of 5.6, standard deviation of 2.3. This is my raw data, okay? If I go through and I say, look at this point right here, sort of whatever that person is right there, they've got a value of, oh no, that's 0. That's what I was trying to point at. So here, my value of 0 is just right here down at the end of the scale, right? If I go through and I now center this variable, I take every value in my set and I subtract the sample mean from it. I've got a new distribution. 0 is now my mean, right? 5.6 used to be my mean. My mean is now 0. This point right here is what value? Negative 5.6. Exactly, right? We're just shifting everything down. Order doesn't change, shape doesn't change. We just now are taking, so whoever was at the mean, they now have a value of 0. Okay. All right. So benefits of centering. Centering was like, people were like super big into centering, and then some of Hayes put out some stuff that was like whatever centering. Right? So the thing is, like, so centering can be beneficial for certain reasons, primarily for interpretation. Okay. Do you have to center? No. Does it make your life easier in terms of interpretation? Sure. Are there certain things in it, analyses that you almost will have to need to center in order to have reasonable interpretations of it? Yeah, probably, right? So in terms of thinking about like why we might go through and center our variables or interpretable models, right? Because now I'm saying if before I'm saying that if I'm interpreting any coefficient, right? This is the relation between X and the unique association of X and Y holding everything constant at 0, okay? Abby, as soon as I go through and center all my models, what does that now mean? This is the unique effect of X on Y holding everything constant at.
I don't know.
The averages?
The average, right? Again, the interpretation of anytime you get a regression model, and you look at a coefficient, the interpretation is always going to be the unique effect of X on Y when everything else is held and the model is held constant at 0. Okay. Your job is to know what 0 means. If I'm working with centered variables, it just means everything else is held constant at the mean, right? Now all of a sudden that means a lot more to me. This is a unique association of X and Y when everything is else held constant at the average, right? Versus this is the relation between X and Y when in the absence of any other predictors, right? And so again, thinking very carefully about like, what does 0 mean for this variable? What does a 0 value represent? Always keep that in your mind because it's going to be critical in terms of going through and interpreting these, okay? So we get more interpretable models because think about what's the nature of an association between X and Y when everything else in my model is held constant at average, right? Versus literally 0 and the absence of anything is a more interpretive way to go about this. Starts to help calculation of my interaction effects. There's some stuff just with the math. Anytime I'm multiplying things by 0, and when I multiply things by 0, they go away and make my life easier. So it helps out here. Also addresses some collinearity that we see with our interaction terms. What will happen is that when you go through and we're going to create our interaction terms, an interaction, if I'm looking at, I've got X1, X2, and then the interaction of those two. The interaction is very literally just the product of those two variables. I'm literally going to create a new variable in my data set that is X1 times X2. Now, if I go through and do that, what's often going to happen is if I have X1, X2, and the product of X1 and X2, I can get high levels of collinearity. Those things are because my product term is the combination of these other terms. I can get pretty high levels of collinearity, right? And so things in my general screening will look kind of not so great in terms of that. Now in OLS regression, this actually doesn't impact anything. It doesn't change your standard errors. It doesn't change your t-test. It doesn't do much of anything. This is why if you read stuff or come across things, Andrew Hayes will talk about this, like you don't need to worry about centering because it doesn't do anything to your model. It has, if you want to interpret because it's helps with interpretation, fine. But statistically, it doesn't change anything in your model, which is technically true until you start to get into things like SEMs, right? Now, all of a sudden, what you start to get is like errors and sort of things will converge in that. And so then it does start to become an impact. In the Aiken and West texts and chapters that hopefully that you're going through and reading, they'll talk about centering as an important way to reduce collinearity. The practical impacts of that are negligible to nothing. It doesn't actually change anything in your model, but it will in other things. And so in general, centering is probably a good practice. And then Kate, what we'll get into is how do we deal with those dichotomous variables? Kind of depends on the purpose of your model. All right. People get an idea of what we're doing with centering? Okay. All right. Centering. This is going to be, again, really important slide here. Is again, like as we start to walk through these more complex regression models, like you should have a series of checks to say, hey, do things look like what they should look like? Okay. Because oftentimes you'll make a mistake and then you have to go through and fix stuff. But you won't know that you need to go back through and fix stuff if you don't recognize that what's going on is backwards. Okay. So if I go through and scale, right? Or if I go through and I set, I'm basically rescaling this by an additive content. No impact on the variability of shape of my distribution. Histogram should look the same. Box plot looks the same. Standard deviation is the same. Nothing changes as a consequence of centering. Okay. If it does, something's gone wrong. Okay. Centering doesn't impact correlations or regression coefficients. and models with no interaction effects. So if we're just doing the stuff that we've done up to this point, straight simultaneous regression, correlation, things like that, centering has no impact on the ANS stuff. Okay. Centering does alter coefficients in models with my interaction effects, except for the coefficients in the highest order term. Okay, so what's going to happen is, and we'll talk about why this occurs. My highest order interaction, if I've got just a two-way interaction, my two-way interaction, the coefficient for my two-way interaction is going to be identical whether or not I center or not, right? If I've got a three-way interaction, my three-way interaction will be identical whether or not I center or not. But anything else underneath that, right? If I've got a three-way interaction, my two-way interaction and my first order effects, or if I just have a two-way interaction, all my first order effects will start to change. Okay. And we'll talk about why that is. So again, a nice check to go through and say, did I do this correctly? If I have, these things should be the same. Everything else should start to sort of move around a little bit. Okay. My simple slopes associated with my multiplicative models, we'll talk about what those are. Not impacted at all. Shape of my simple slopes doesn't change at all. It's just those first order effects that are the only thing that we'll see as an impact. Yeah, Johnny.
Could you just, I think you just said it, but would you mind saying it again? That what is the highest order term again?
So it depends on how I've structured my model. But the stuff that we're going to do, it's all two-way interactions. So my interaction is my highest order term in that model. So if I have a two-way interaction or a series of two-way interactions, my first order effects are just sort of my main effects, right? The stuff going down there. But if I have a three-way interaction, now all of a sudden I've got a three-way interaction. So my two-way interactions are, so my three-way interaction is my highest order effect. What I'll start to see is now that my two-way interactions start to jump around in a centered versus an uncentered model, right? Along with those first order effects. So when I'm talking about highest order effect, I'm just talking about the largest interaction that you have included in your model.
Thank you.
Good question. Any other questions? All right. It's like, I don't know if I got like just a terrible clicker, if I just have 4 batteries. Oh.
I like how you're pointing it towards the.
It's just like. It seems to be like sort of more effective that way. All right. Whatever, right there. All right. Our straight multiplication, our straight multiple regression in this example, right? So here we progress role functioning onto pain, opiate use in PTSD. Okay. So I can very literally take this and based on my model, project an expected value of role functioning based on the value for pain, opiate use in PTSD. Okay. So if we go through and someone tell me someone give me a literal interpretation of B1. Lindsay, can you tell me how I would interpret this coefficient? What does this coefficient represent?
I'm not sure like what the B is standing for.
Okay, so this is your coefficient for pain.
Okay.
Let's say it's 2. All right, what's the interpretation?
The magnitude of the effect of the moderator.
Okay. So it sort of represents the strength of effect, but if I want to give it a literal interpretation, how would I interpret that? An unstandardized coefficient of 2. Someone help her? Johnny?
It's the slope. So it would be, let's make sure I don't mess this up. A 1 unit change in pain leads to a X unit change in Y.
Right, so this is, let's say it's 2, right? It's just saying. Holding everything else in this model constant at 0, like controlling for everything else in the model. What I would say is for every 1 unit increase in pain, I would expect a 2 unit increase in role functioning, right? And the same thing here, right? Opiate use, this is a 0, 1 variable you're using or not, right? So for every unit increase in opiate use, let's say this is 10, right? Every unit increase in opiate uses corresponds to a 10 unit increase in role functioning. Now, what does a 1 unit increase in opiate use represent? You
You
don't
don't
know.
know it.
If it's coded 0, 1, use or not, if it's a dichotomous variable, what are we talking about? Using someone who uses, like, so if I'm using opiates, I expect a 10 unit increase in functioning after I account for pain and PTSD. So essentially, what is this? If this is telling me the expected change associated with opiate use, what is this coefficient essentially giving me? How many groups do we have? 2, right? This is essentially like a t-test controlling for these other, it's literally giving me the expected difference between people using opiates and people who aren't after we account for these other things. Right? And so like we said, oh, 1 unit, and so this will start to be important in terms of like thinking about your interpretations with dichotomous predictors. You say, oh, well, a 1 unit increase in this will be associated with an expected increase or decrease in Y. Technically, that's not incorrect. Essentially, what you're saying is like controlling for everything else, we got a 10-point difference in people not using opiates versus people who are, or people with opiates are using sort of 10 points higher than the other group after we hold everything else constant at 0, right? So again, starting to like think very critically and sort of concretely about what do these coefficients really represent. This is just a mean difference after we control for other stuff if we got a dichotomous predictor. Okay. Same thing here, PTSD, let's say it's -3. For every unit increase we see in PTSD score, we would expect a 3 unit decrease in role functioning. Okay. Again, I want you to be very, very clear, both for this stuff and for the stuff that you're working on right now, what these coefficients are literally looking at. So yes, Lindsay, they are a raw index of the magnitude of the unique association between a predictor and an outcome after we sort of account for everything else in the model, but they're also very literally telling me like for every unit increase in this thing, based on my model, this is the corresponding effect that I would expect on my outcome. Okay. So, and this is also starts to become where we need to start thinking carefully about what does a 1 unit increase mean, right? Is a 1 unit increase a lot? If I've got like a 1 to 5 scale, that's a lot. If I got a 1 to 200 scale, that's not a lot, right? So wanting to think carefully about what these represent. Okay. Last question. What does B naught here represent? Allison? Yeah, okay. This is my expected functioning when pain, opiate use, and PTSD is held constant at 0, right? Now this, Abby, is where we can start thinking about like, what does that actually mean, right? Well, it means if I have someone with no pain, who's not using opiates, who has no PTSD, this is what I would expect that person's functioning to be at, right? Versus if I center this model, except for maybe my opiate use, now I'm saying this is the expected value of my outcome for people at average levels of pain and average levels of PTSD who are not using opiates, okay? Like stick this in your brain because it starts to do really, really cool stuff and you start to get a really good understanding of what's happening. And then we can start to get really flexible with these models and start screwing around with that 0 value to start to ask very precise questions about what my model is expecting at different levels of stuff. Okay.
So can we say that again? So when it's centered, we're essentially saying that it would be like the expected role functioning when everything is held at average.
Right.
Okay.
That's Well, so if I have a centered solution where I've centered my continuous variables.
Right.
Yep, then that's average levels of pain, average levels of PTSD, because I've set zero to be equal to the mean of those variables, right? In my uncentered solution, it just means when there's no pain or no PTSD. Okay. Now, Kate, when we get into our moderation models, sometimes you're not going to center these, and sometimes you are. It depends on what you're trying to test. If I go through and I center that opiate variable, then it just means it does anybody in my set actually, if I center this, does anybody in the set actually have a value of 0? No, that doesn't correspond to anybody. What I'm essentially saying, I'm controlling that. Holding opiate use constant. So if I center opiate use, then I'm saying this is the expected value of role functioning for people at average levels of pain and average levels of PTSD, holding opiate use constant. If I don't center that, then it's average pain, average PTSD for people who are not opiate users, right? Or maybe I want to flip that around. I would go through and recode it. 0 is opiate use, 1 is not. Now all of a sudden I've got the thing looking at expected value, average level of pain, average level of PTSD with opiate use. And so this is through this way we can start screwing around and sort of recoding our variables so that 0 means what we want it to mean. And then we can go through and start testing very specific effects.
You can center some of the variables and not others.
What's that?
You can center some of your variables.
Yeah, you don't have to have everything like, because it doesn't matter. All you're doing is you're sort of impacting interpretation. So you get to choose which ones you go through and center, which ones you don't. Johnny, did you have a question? Abby, did you? Okay, yeah.
Can you say that one more time? If it's centered, we're holding constant, so if they're using for the opioid examples, it's dichotomous.
Yeah.
And
If
it's,
we- yeah, if we center this, Danielle, we're just saying, we're not saying that people are using opiates or not, we're just saying we're holding it constant. They should have averaging across opiate use. So this would be the expected value of role functioning at average levels of pain and average levels of PTSD, just controlling or holding opiate use constant.
okay, and if we're not, we're saying if nobody was doing this at all.
Yeah, if this was
Okay.
0, we're saying that this is the expected effect for someone who's not using opiates. Right? So again, it starts to become really critical to think about what does 0 mean in my regression model, okay? People kind of comfortable with it, or at least, yeah,
I think I'm still just a little bit lost with like the opioid examples, like the dichotomous
yeah,
variable when we're centering, like I know we're not centering like the opioid variable because it's dichotomous, but I'm just confused, like why, what does like holding it constant mean, I guess, like, cause I thought like it would be like putting in a 0,
yeah.
which would
It
then.
just means, it still literally means it's the expected value of your outcome with pain, opiate use, and PTSD held constant at 0. It's just holding this constant at 0 doesn't refer to anybody. It's just saying like taking it across, sort of aggregating across everybody essentially. Okay. And there are reasons when we get into our moderation models where that might start to become a useful thing. Yeah.
I think what Steven's really just saying is that opioid, like no use is 0.
Mhm.
So when you're saying holding it at 0, it sounds like you're saying like no use.
Yeah. If I haven't centered it, if I just got this 0, 1, where 0 is no use, 1 is use, then this is the projected outcome at average levels of pain, average levels of PTSD for people not using opiates, right? Now, if I center this, and we'll talk about like why that might be advantageous in terms of interpretation stuff, we're just saying, just kind of averaging across. Okay, we'll get into this and talk it because it's a weird thing. And if there's certain codings where I certainly don't want to center things because it'll screw things up. But we'll go through and talk about those. Okay. So in my centered solution, we're gonna center pain and PTSD at their respective means. Gonna here center my dichotomous opiate indicator so that non-use is -5 and use is 0.5 in a balanced design. Okay, so literally we're going to center our dichotomous variables the same way we center everything. We're just going to subtract the mean. In this example, we're going to go through and do, and like everybody's eyes on me. Like this will be when I go through and I subtract the average level in a balanced design where half my sample is using opiates, half the other half isn't. People who are not using are gonna be negative 0.5. People who are using are gonna be 0.5. But this is only gonna happen if you have sort of equal numbers. If I don't, these values are gonna be different. Okay, so please, please, please center your dichotomous variables the same way you did center anything. Don't just go through and say half of them negative 0.5, the other half to 0.5, because unless you've got exactly equal proportions, which you almost never will, it'll be off. Okay. All right, so if I go through and I do this, right, and I go through and I center my all of my variables, what I get is a regression equation where my intercept is 48.2, negative 10.71 for centered pain, negative 0.69 for centered opiate use, negative 0.23 for centered PTSD. Right, and that's just my regression equation. Same regression equation you've been running the whole time. Okay, and we talked about interpretation of coefficients. This is saying for every unit increase in pain, I'm expecting a 10.7 decrease unit in role functioning. Here, I'm saying for every unit increase in PTSD, I'm expecting a 0.23 unit decrease in role functioning. Here, for my centered opiate predictor, I'm saying basically this is saying a 1 unit increase in opiate use corresponds to a 0.69 unit decrease in role functioning. It is technically correct, but what I would look at that is saying there's a 0.69, so people who are using opiates are scoring about 0.7 units lower on role functioning, right? This is to give me the difference, right? And then here is what I'm saying, or this is my expected value of role functioning at average levels of pain, average levels of PTSD, controlling for opiate use. Yeah, Haley. Okay. Right. Did people see how this follows from the discussion that we had above? And it's sort of, again, getting very, very concrete and very literal in terms of what these coefficients represent. All right. So just a comparison. In SPSS, here's my uncentered solution, here's my centered solution. And going back and remembering sort of the stuff that we had talked about, R squared in my uncentered solution, 0.376, centered solution, 0.376. Nothing changes. My F value, my P value for my model, my test of my R squared, that's going to be identical. My pain, my coefficient for pain, opiate use, PTSD, identical. Everything else is identical. Where's the one thing that we're seeing a difference in? Yeah.
Constant interaction.
Yeah, and why does that make sense? So here we've got in my uncentered solution, I've got an intercept of 67.5, and in my centered solution, it's 11.8. Why are we seeing that, Kate?
We're just moving where the intercept is.
We're moving where the intercept is, and remind me, what does the intercept mean? What does the intercept represent? What do we say, Jalen?
When all are set at 0.
What's that?
The outcome is when all are set at 0.
When everything else is held constant at 0, right? So thinking about this, like, this is a critical check when we're doing this type of stuff. Like, okay, if my understanding about this is correct, do my data make sense, right? So here, this is my role functioning, expected role functioning when for someone who does not have pain, who's not using opiates, and has no PTSD. Well, then my expected value of role functioning is 67. Okay, my centered solution, this is my expected value of role functioning for people with average levels of pain and average levels of PTSD, controlling for opiate use. My expected value is 11.8. Does this make sense? Yeah. If I have someone at average levels of PTSD, average levels of pain, and sort of controlling for, I would expect their role function to be worse. That's what we're seeing, right? So again, like thinking critically, like, does this, can I close the loop on this? Is what I'm seeing in my model make conceptual sense with what I know should be happening with these variables? is such a critical sort of check on this stuff, because there's just a lot of steps in making sure that things are performing the way that they're supposed to be performing based on your understanding is gonna be essential for not getting off the wrong direction of stuff. Okay. So again, uncentered solution, centered solution, nothing changes except for that intercept. Everything else is identical. So here, sort of looping in, Jim, if I'm looking at this, it doesn't matter which model I'm looking at, what am I seeing here in terms of evidence for effects?
We're seeing that there is an effect on role functioning due to like pain severity and PTSD total score.
So I'm going through and I'm looking at and seeing I have evidence, pretty clear evidence for an effect, a unique effect of pain severity and PTSD on role functioning. Opiate use, once I go through and account for these other two variables, doesn't look like it's having much of an effect at all, right? No unique association. Jim, which one of these effects is stronger? Pain severity or PTSD in this model?
Pain severity.
Pain severity, how did you determine that?
Well, number one, like the P value is like smaller, but then I don't know, I looked at the B.
Because we got a couple of B's, right? So we got to be
I
careful.
looked at the unstandardized B.
Okay.
That was a guess. That was based on 5.
What is the problem with sort of looking at your unstandardized coefficient, Haley?
Well, that I don't know, but I was going to,
I knew it was problematic, but I did it
Okay.
anyway.
but I do know like.
Sometimes we do those things. Johnny, what's the problem with looking at your unstandardized coefficients?
It's a biased estimate, isn't it?
Not really biased necessarily, Abby,
Because since it's in their raw units, they're not like directly comparable.
in their raw units, right? So it's not biased, it's an unbiased estimate. It's just they're not comparable, right? My pain scale goes from like 1 to 8 and my PTSD scale goes from like 0 to 140, right? So a 1 unit change is not the same across my pain scale and my PTSD scale. So I can't look at my unstandardized coefficients and say anything about anything, right? But what coefficient can I look at to start to look at relative magnitude of effects?
You can look at the beta.
Yeah, my standardized coefficient. I look at my standardized coefficient, I see a standardized coefficient of negative 0.56 for pain severity and negative 0.18 for PTSD. That's just telling me that within the context of this model, pain severity has a stronger association, a stronger unique association with role functioning relative to PTSD. And then if we go through and take a look at my effect sizes here, here's my partial correlation, negative 0.55 versus negative 0.21. Here's my semi-partial, right? If I square that semi-partial, this is telling me the portion of total variability in role function that's unique to each one of these predictors, right? I can square my partial coefficient. That's telling me the proportion of residual variability that's attributable to my outcome, right? So there's a couple of different ways we can go through and start to evaluate magnitude of effects within the context of this. My unstandardized coefficients are nice because they give me a very literal interpretation of per unit increase in my predictor, what's the corresponding impact I would expect on my outcome, but not so good at being able to sort of gauge relative importance. This looks like it's way bigger than that, and it turns out it is, but not because of those values that we're seeing there. It's because of the difference there. Yeah.
So just to confirm, it would be more appropriate, like we talked about that interpretation on the last slide, like the actual interpretation
Yeah.
of B in terms of like units. So when we take like the square of, like the semi-partial, we would talk of that we would rather do that and talk about it in terms of a very like percentage rather than a unit increase.
Yeah,
Okay.
Yeah, this is not a unit increase, this is just
Right,
a percentage.
and that would be the more appropriate way to do it than looking at the unstandardized fee and talking about it in terms of unit.
Well, it depends on what we wanna talk about, right? Like,
Okay.
so if I want to, and we rarely do this in psychological science, like rarely are we making specific interpretations about. Unit increase in this is expected to correspond to unit change in Y in terms of this, because a lot of our scales are just arbitrary, it doesn't matter, right? But sometimes we do things where scales are meaningful and they do matter, right? So Lindsay, if you're doing like weight-based stuff and eating pathology things, you say for every unit decrease in mass in terms of pounds for this person, this is the expected change in some outcome. Now all of a sudden we've got a unit that means a lot, right? And it has intrinsic meaning to me if we're talking about risk for something, right? Now maybe a pound is too fine a grain thing, maybe we say like every 5 pounds, but that's easy, then we just take this and multiply it by 5, and now we've got sort of corresponding things. So we can start to go through and use these types of coefficients. Some people are interested in some like SES variables, right? Okay, right, so if we're looking at, if we have like literal income as a predictor, those are dollars, that makes sense to me, I know what dollars are right now. For every dollar increase in something, that's probably not so helpful, but for every $1,000 increase or something like that, now all of a sudden that unstandardized coefficient might be quite attractive in terms of like communicating sort of how much change we're getting with change in sort of income or something along those lines, right? What we want to do is know what everything is going on here so we can decide for our project, like what's the best way to go through and communicate in a meaningful way what's actually happening, okay? And so we're just giving some different looks at stuff like we have all semester. So Haley, if I want to do very literally, like looking at, if I had some predictor looking at sort of jury, something like if I go through and increase this by a unit, this is the expected increase that we would expect in sort of competence of guilt or something like that. That might be a very meaningful thing to interpret, right? But if I just want to interpret broadly about the strength or the magnitude of the association, then maybe it's sort of my effect size here is something that might be a better way to go through and communicate stuff. That all kind of depends on the circumstances. Other questions about this? So, talk about additive models when we started out with GLM stuff, right? And sort of thinking about when we introduced this moderation question, the whole idea behind moderation is to look at the change in the relation of a predictor and an outcome at different levels of my moderator, right? So again, Mesa, you're looking at the relation between, let's say how the relation between hyperactivity and sort of behavioral referral score differs across boys and girls in school, right? And you think that the relation between hyperactivity and behavioral referral score differs maybe for boys versus girls, which is probably a reasonable hypothesis, right? This is what we're trying to do. We're saying that this sex variable has an impact on the association of these two other variables, right? And so what we can start to do, if we go back to our example, sort of like starting to take a look at like our question, this one was, what's the relation of opiate use on role functioning at different levels of pain and PTSD, right? So here's our model that we went through and estimated, okay? What we can do then with this model is, what we can literally start doing is just plugging different values in for high pain, high PTSD, like pain, PTSD, opiate use, things along these lines, okay? So let's say I'm interested at the relation between high pain, or sort of looking at role functioning at high pain and high PTSD. Right, people follow me what we've done, what we're doing here? Okay. So I go through and I just take my equation and start plugging in the association of opiate use with role functioning at high pain and high PTSD. So I go through and I take the values here, high pain because I've centered, standard deviation above is 1.34, standard deviation below, negative 1.34. makes this really easy, right? Because 0 is my middle value, standard deviation above is plus, standard deviation below is minus, right? So I plug in high pain. And then high PTSD, standard deviation is 19.76, so standard deviation above 19.76, below negative 19.76, drop that in, okay? So what we're looking at is the relation of opiate use and role functioning at high levels of pain and high levels of PTSD. See what we're doing? Okay. So if we go through and we multiply this out, right? So this is now a number, that's a number, we go through, consolidate our terms. We get a reduced equation where we're saying that the relation of opiate use with role functioning, and here's my intercept. So people at average, this is going to represent the average functioning across opiate use, right? But my coefficient here is 0.69. Okay. Seeing that? Okay, this is marking the nature of the association between. So this is my expected association, my unique effect of opiate use on role functioning at high pain and high PTSD. So let's go through, and if I were to go through and put in values for no opiate use and opiate use, but no opiate use is negative 0.5, opiate use is 0.5. I get no opiate use, role functioning is 29.6. For 7, opiate use, 29. It's a difference of 0.69 between those two. Okay. People see how I just used math to sort of plug in values to get from here down to here? Okay. All right, cool. So we know what's going on at high pain and high PTSD. Let's change things around. Let's go low pain and high PTSD. Completely switch this around, okay? So again, still going to start with my same equation, right? But this time I'm going to put in a low value of pain, right? High value of PTSD, work this out. What I end up now, my intercept is different, but my coefficient for opiate use is the same, right? I've still got negative 0.69, right? And if I go through and I work this out, put in the opiate use, I get now for no opiate use for people with high levels of PTSD and low levels of pain, an expected value of 58.4, opiate use 57.6, but again, it's still a difference of 0.69. So did anything that I did in terms of substituting in values of pain and PTSD, did that change the unique effect of opiate use on my outcome? No, it didn't do anything, right? Which I'm kind of bummed because what I want to know is sort of how opiate use impacts this stuff, right? But I'm swapping out different variables and nothing happens, right? Same thing if I want to know what the relation of PTSD to functioning is at different levels of pain and opiate use. Again, here's my model. Let's switch things around. Let's say low pain and opiate use, okay? So low pain, negative 0.34, opiate use is 0.5. Reduce this down, I get an effect, a unique effect of PTSD on functioning negative 0.23. Right? I go, okay, what about high pain and no opiate use? Like completely opposite directions. Go through, plug things in, get the same value. Okay. So all of this is to go through and say, in my standard additive models, right? If I just have a model with first order effects, the slope of X on Y is the same across all level of predictors. Like it doesn't matter what value I plug into for my other variables, the relation between my X and my Y is always going to be the same by design. Okay, so if I have a straight additive model, it doesn't matter what values I put in. I can plug in whatever values I want. They can be ridiculous values. I can throw 10 billion in there. It's not going to change the nature of the relation between X and Y within this additive model, okay? There's nothing that I can do to go through and take a look at this. And so if I go through, here's my effect for low pain and opiate use, here's high pain and opiate use, here's the regression model, but the slope's the same. It changes kind of the sort of the level at where it's at, but it doesn't change the actual value, right? I've got parallel slopes. So all of this is to demonstrate that with my straight additive model, my simultaneous regression, can I look at moderation effects with my straight regression model? Nope. There's nothing I can do. It doesn't matter. I can ask the question, but the way I've gone through and estimated that, it doesn't matter what values I throw in for everything else, right? So this is the thing. What happens when we're interpreting our simultaneous regression, right? If I'm looking and interpreting my coefficients, my coefficient represents the unique effect of x on y holding everything else constant at 0. It really doesn't matter what I hold other things constant at, because it doesn't matter, because it doesn't change the nature of that association. There's no way in a straight additive regression model for any one variable to change the nature of the relation with something else. I mean, if I have it in there, then if I have it in the model, then it changes the coefficient, but changing the actual value once it's in there doesn't do anything. So I can't actually test my moderation question in my standard additive model. Okay. So when we're going through and we're interpreting when I'm interpreting my regression coefficients, anytime I ask you to interpret a coefficient, this is saying this represents the unique effect of x on y when everything else is held constant at 0. That's a correct answer, and that is a true statement, and that is very literally what's happening. The thing is I can go through and I can hold all those other variables constant at whatever the hell I want, and it's not going to change that association because it can't. The model won't allow that to go through and happen just within that. So holding everything else constant at 0 is absolutely correct. It's just the 0 value doesn't actually matter outside of what the intercept is, because changing those values around doesn't change the nature of the relation between these variables. Okay. So if I have regression questions, these are things I want to ask. Is my standard regression model capable or suitable for doing that? Can't do it. So what we do then is we include our interaction terms. Okay. Once we go through and we include our interaction terms, now we've given that model a way to start changing the nature of the relation between x and y based on other variables. Okay. So let's stop there. Let's take a break. 3:25. Come back 3:35, and we'll jump back into the math and the algebra for why this works. Oh, calm down. Said math and algebra, and we got too excited. I thought we were going to call teams of police. Not too much. We got into the like activity levels, arousal levels got. Also, Olivia thinks I'm way too funny, and so we need to get her carried out of here.
Gonna die during class, and I was like, I think never let your eyes touch class. IT company.
I'll do it if you want to. If you like. Like 15 last week.
What's that? What's
There you go.
Yes.
People in the back, I saying about us.
See, it's not just us. Be his favorite class ever.
Or Robert.
Like I thought you were telling me that like I was your favorite class.
Yeah, that's who.
Slow down, sad and shut down. Not talk about the statistics.
Another period.
All right. Let's jump back into this just so we can kind of keep moving with stuff, right? So we go through, talk about like mathematically, when we set up our multiple regression model, there's just no way to go through and test our moderation question, right? Because it doesn't matter what values for my other variables I swap through, my coefficients stay the same. It doesn't change anything, right? So what we need to do is we need to include interaction terms within our model to start to look at the extent to which some third variable starts to change the association of some other predictor with our outcome. Okay. So again, we want to ask, do opiate medications influence the impact of physical pain on role functioning in people in accident survivors, and then does pain change the severity or pain severity change the relation of PTSD and role functioning again in the same population, right? So what we would do if we wanted to test these, what we would do, we've hypothesized two interactions, right? Two moderation effects that involve different combinations. Yeah, I went through and got it. It's up and going. Yep. I'm gonna stop it and then start it again just to make sure. It's all right. We just, it's like,
I can hear it.
I just want the confirmation. So we've got two effects going on here, right? And so what we need is two interaction terms to go through and account for this, right? So what we've done is we've got our pain, our opiate use, and our PTSD, but now we've got interaction of opiate use and pain, which is going to give us this first one, right? The influence of physical pain, opiate use and physical pain on role functioning, and then PTSD and pain on role functioning here. So we've included two interaction terms to test specifically these questions that we have. Okay. Opiate times pain. This is testing the hypothesis that the relation of pain and functioning depends on opiate use, pain by PTSD. This is looking at the impact of the relation of the dependency of pain and functioning on being dependent on pain severity here. Okay, but again, we talked about this before. Realize that these interaction terms are mathematically symmetrical. They're not inherently testing sort of a hypothesis in a specific direction. I could these two things. If I had a question about the impact of pain on the relation between opiate use and functioning, it's the same interaction. If I wanted to look at the impact of PTSD on the relation of pain severity and outcome, it would be the same interaction. Okay, so there's nothing about these interaction terms that say you have to look at this one way or the other. This a lot of times breaks down to asking about what is my base relation? What is the thing that is kind of been determined either by theory or existing research as kind of the base thing, and then what is my moderator? If there's nothing in the statistical model that says, oh, this has to be predictor and this is the moderator, it's interchangeable. Okay. Now there's some situations where we might start looking at some of those first order effects to try and something might make more sense one way as opposed to the other. But this is all a conceptual question, right? So you want to be thinking carefully. How do I want, given the literature, given the theory, how do I want to describe this? Do I want to describe this as the relation of X1 on Y at different levels of X2? Or does it make more sense to talk about this as the relation between X2 and Y at different levels of X1? Okay. I'm going to go through, provide you guidance, sort of set up and sort of theoretical questions to go through and guide kind of how you should be looking at this. But you need to be thinking about that as you're going through and going through and looking at your probes, because you get a different set of follow-up tests depending on how you're looking at this. Okay. So let's say that we're looking at a more basic model. Okay, because right now we've got two interaction terms. Let's pull back on that and just look at one interaction term. Okay, so we've got a different model. What we want to look at is whether or not opiate use influences the relation between pain and functioning. Okay, so here we've got my intercept, predictor opiate use, pain, and then the interaction of these two. Simplest interaction model that we can go through and specify. Two predictors, interaction. Okay, people take the leap with me to see what we're doing, like sort of different question here. Okay. All right. So here's my regression equation. What we can do in the absence of any statistical software, once we have estimated my model, what I can do is I can start to restructure this equation to start to make it more clear how, in this conceptualization, pain or opiate use might impact the relation between pain and functioning here. Okay. So we're going to go down through, and this is who's sharp on their algebra, like just come out of like 8th grade math or something. Basically what we're doing, like everything we're doing here is just basic algebra skills, okay? It's just combining terms and stuff like that, okay? We're just factoring things out. So, but if you're not super sharp on this, because it's been a long time, I've got a kind of a system to go through to help you go through and make sure that, because you for sure will need to do this. I am telling you now, you will for sure need to do this, so I would know how to do this for things that come up in the future, all right? So make sure you understand this. What we've got here is an equation where we've got one term, two term, and the product of these two terms. We can take this and re-represent this by factoring this stuff out. Okay, so what I'm gonna first do is I'm gonna pull down anything that doesn't involve sort of the effect that my main effect that I'm looking at. I want to look at my base relation is the relation between pain and functioning. So any term that doesn't contain pain, I'm just gonna go through and pull down, okay? So I've got my intercept, opiate use, neither one of those things involve pain. So I'm just gonna carry those things down. Okay, see what I did there? So again, making sure that I understand what's my base relation. Pain and role functioning, well, I've got a term that involves pain and another term that involves pain, so I'm gonna hold off on those. Everything else I'm just bringing down. So now what I'm gonna do is I'm gonna go through and I'm just gonna bracket off. I've got two terms that involve pain. So what I'm gonna do is I'm gonna set up brackets. And so this is gonna be the relation of pain here, right? You'll see what I'm doing? And then what I'm gonna do is I'm just gonna pull down these terms here and drop them in my bracket. So I've got intercept opiate use, but then in my bracket, I've got negative 10.05 for pain. Well, I brought down 10.05, pain's right there, right? So we're good. And then we've got 4.60 opiate times pain. Pain's already taken there, drop down that 4.6 opiate, right? Okay. So do people see how I kind of factored that out? You go through, and again, this is just basic like middle school algebra. Always, once you factor this equation out, check it, right? Go through, so I've got this, and then if I take 10.05 times pain, 4.6 opiate times pain, if I get back to what I had at the start, then I've done it right. If you made a mistake, you'll end up with something different. You didn't know you need to make a mistake, that you made a mistake and need to go through and correct it, okay? Is this task sort of ringing like sort of faint bells from like middle school stuff? Okay, good. This is when you're like, when will I ever use this? Thank you, sixth grade teacher. Okay, so now what we can go through, if I want to go through and I want to look at the relation between pain use, or excuse me, between pain severity and role functioning for people who are not using opiates. Now all of a sudden, if I go through, and so people in our set who are not using opiates is negative 0.5. I throw negative 0.5 in there for any opiate use, drop that in, and go through and pull these out, and I get an effect of pain on role functioning for people not using opiates. Okay, if I do the same thing, and this time substitute people who do have opiates are represented by individuals with a value of 0.5, drop those in there. Go through, work this out. Now I have a different slope. Now all of a sudden with this multiplicative model, and I can see this, right? If I go through and I take a look, the relation of the coefficient for pain with role functioning depends on what value I have for opiate use. And as I start to change that value for opiate use, this coefficient for pain just gets changed around, right? And so now all of a sudden I've created a model where the relation between pain, the unique effect of pain on outcome is dependent on opiate use, right? So the value that people have, whether they're taking meds or not, is going to change that association with pain, or change the effect of pain on my outcome. Okay. So mathematically, can people see what's going on with this? And what we've done is we've essentially what we call these simple slopes, right? Or the simple main effects. This is looking at the simple slope of the effect of pain on role functioning for people with no opiates. Here's the effect of pain on role functioning for people who have opiates. What we can do is we can go through and plot these out and look at the differences in sort of the strength of this association across these two different groups. We couldn't do this before in our straight additive model. There was no way for the model to go through and change the nature of this association across different levels of the other. But as soon as I include this interaction, now this interaction is allowing for the possibility for the relation of pain and outcome to be dependent on opiate use, or the relation of opiate use with outcome to be dependent on pain, however we want to set this up. Okay, you will kind of see the math on how this works out. And conceptually, why now all of a sudden, if I start screwing around with this pain value or this opiate value, it starts to change this coefficient. Okay. So let's go through it and take a look and sort of take this, extend this back to our full model where we have more predictors, a couple of interaction terms. Okay. So if I go through and I regress my outcome on all of my predictors, this is what I get. Okay, this is my equation. So I got a coefficient negative 0.68 for opiate use, negative 10.05 for pain, negative 0.19 for PTSD, 4.6 for the interaction of opiate use and pain, 0.17 for the interaction of pain and PTSD. This is my full model that I just went through and calculated. So what I want to do is I have two different hypotheses here, right? I'm saying that pain is going to impact the relation of PTSD and functioning, and that drug use, opiate use, is going to impact the relation of pain and functioning. Okay. So these are my two hypotheses here. Follow me up to this point. So what I'm going to do, I'm going to restructure the equation the same thing as before, right? What are my two base relations? Look at the relation of PTSD and functioning and pain and functioning. So I'm going to drop down anything that, well, first I'm going to drop down my my intercept, because the intercept is fine, it just broke down. Okay. Then opiate use, that's not part of my base relation, so I'm just going to go through and drop that down. So I'm fine there. Okay. People follow me in the steps. Now what I'm going to do is I'm going to go down through and I'm going to bracket off my two conditional effects, right? Because these are no longer main effects. These are conditioned on levels of the other variable. Okay. So my two conditional effects, I'm proposing a conditional effect of PTSD, a conditional effect of pain, right? So I'm just bringing these two things down. I'm creating some brackets. Something's going to go in those brackets. Need to turn them, figure out what's going on. Okay. So first I'm going to address pain. What I'm going to do is I'm going to pull down of my remaining terms anything that has pain in it, right? So I've got my coefficient for pain and then this interaction that has pain in it, right? So I'm going to go down through drop negative 10.05, 4.06, opiate use, pull pain out of both of those because that's out here, and I'm left with this factored out the way I want it, right? I'm left with PTSD. My last two terms are both my terms that have PTSD. Pull those down and drop those down to here. Critical issue. Everybody look at me real quick. Do not screw up your signs. You screw up your signs, throw everything off base. It'll happen. We'll do it. You'll screw it up and you'll figure it out and you make, God damn it. And I got to go back through and fix it. Okay. Be very, very, very careful as you're sort of looking at these signs, because those need to come down in order for your model to make sense and to factor back out. Okay. Here's my full factored equation based on sort of the conceptualization I have. Always double check this. Go back through. So this, I get negative 10.05 pain, 4.60 opiate times pain, negative 0.19 PTSD, negative 7.17 pain times PTSD gets me back up to here. Always make sure that you get back to this once you've got your factored equation, because there are ways to screw this up. And then when you multiply it out, you don't get back there. Like, okay, I made a mistake somewhere. I need to start back again. Yeah.
How did you know, since we were taking everything that said, like, that had pain in it? In the
What's that?
last, like, we were bringing down everything that had pain in it, but we didn't bring down, is it because it had pain and PTSD?
Yeah, because it had
We needed-
PTSD. Yeah, because it had pain and PTSD both in there too.
Okay.
So here we pulled down pain and opiate use times pain. So there's pain things that's going to correspond to this piece. This is my PTSD. You can't pull that down because PTSD is a conditional effect, and so that's out of the mix. Okay. This is kind of my step-by-step system to go through and help all of you. If this isn't necessarily the step-by-step sequence you might necessarily follow in middle school algebra, but like, this will get you to the right solution if you go through and follow these steps. Okay. Or if you just sort of understand what's going on with this, just do it however you want to do it, like, I don't care. Okay. Yeah, Lisa.
Just a little confused why the 0.7 was pulled down for PTSD and not pain.
What's that now?
Essentially what Haley just asked, why
Yeah.
the 0.17 was pulled down for PTSD rather than for pain.
Because here we don't have any, this is capturing this effect here, right? So we're pulling down, pain, in this part here. Okay, what's involving pain? Well, and think about this is stuff that's involving pain that's relevant to this interaction. It's pain and opiate use and pulling that piece down, sort of covering that piece of things. And then what we're left is PTSD and PTSD times pain. Pain is here, but that pain is involved with this sort of multiplicative effect of PTSD, so we're holding that out. Okay. So again, it's sort of having a good sense, draw these pictures, sort of go through, like, practice this as a way to go through and factor these out. It'll take a couple of times, you get turned around, work together. Once you kind of get the rhythm down, you're like, okay, this is going right. And if you make a mistake, you're like, oh, whoops, this is what's going on. So we get everything turned back in the right direction. Okay. So, and if we've gone through and we've done our restructured equation correctly, right, we can see that the effect of pain on role functioning now depends on opiate use, which is consistent with what we've got here. We can also see that the effect of PTSD on functioning is conditioned on pain, right? This is telling us that what we've done is correct. It's consistent with our conceptualization. The relation of unique effect of pain on outcome is going to depend on what value I put in for opiate use. The effect of PTSD on outcome is depending on what value I put in with pain. This all maps onto the stuff that I'm wanting to do here, right? So we know that we've done this correctly. And because of this, is if we have evidence for these interactions in our model, it's going to tell us that this can affect this effect of pain, this effect of PTSD. These are now conditional effects, right? I can't tell you what the relation of PTSD with role functioning is unless I know the level of pain based on this model, right? Because it's going to change. Depending on what value of pain that I put in from 0 to 8 or whatever this is, any different value is going to change that coefficient a little bit, right? Now, whether or not it changes it enough to be something that we would interpret as evidence for effect, that's what we need to go through and run this through our statistical model or our software to sort of be able to determine. But in the presence of these interactions, all of these are all of these, because they're all involved in it. These are all now conditional effects, not main effects. Yeah, Johnny.
I just have a quick question. So, they're like different conditions, that makes sense, but just conceptually, essentially then, isn't PTSD, depends on opioid use?
PTSD. Can I throw in different values of PTSD to change the effect of opiate use on outcome? Is PTSD involved in an interaction with opiate use? No. Then PTSD and opiate use are completely orthogonal to one another, right? The reason these are all now conditional effects is because opiate use is involved in interaction with pain. Pain is involved in interaction with both opiate use and PTSD. PTSD isn't involved in interaction with pain. And so now all of these coefficients are going to change depending on what values I plug in for other things. So everything, all my first order effects are now conditional effects because they're all involved in some way with a higher order interaction. Yeah, Lisa?
This might be a really dumb question,
It's
but
probably
if
not.
there are two models, like looking at like the graph,
Yeah.
if they're two separate models, why did we combine them into one equation?
Well, we did this is the one equation.
Why did we combine them if they're two separate models?
Well, so why would I, are you saying why not just run this model separately than this model? You could, but if I do this, what I'm saying here is I'm making a statement about a complex model about how these three variables interact with one another. My working model here is that the relation of pain and an outcome in this population that has pain, they're using opiates and they have PTSD, that these, if I didn't have, remember that we talked about in terms of an assumption of regression is having a properly specified model, meaning that everything's in there, that everything that needs to be in there is in there, and nothing that isn't in there. Having worked with this population, probably if you're not accounting for levels of PTSD and levels of pain, levels for opiate use, at least when we were going through and collecting these data, this was mid to late 2000s. They're handing out like opiates like candy, like it was really, really egregious, right? And so people come in with multiple chronic pain, sort of things along those lines. If I don't have all of these variables in there, the results I'm getting are biased because it's not, the model's not accounting for big things that need to be accounted for in there, right? So what I can do is more efficiently is just look at this all in the same model, right? So I'm saying in this model, opiate use, pain, and PTSD, all critical variables in determining functioning. But what I'm saying is the level of pain, the association of pain and functioning is going to change depending on the opiate use. The level of association with PTSD with outcome is going to be dependent on pain. So what I'm doing is I'm just making a very specific statement about how I think these variables work together. And then what we can go through is, and go through in this model is test sort of how these things work together simultaneously, as opposed to breaking out a couple of simple regressions independently. So, right, we've got compounding error, sort of a lot of things that the model's missing stuff. We just run it all together, a nice efficient way to test everything all at once. Kind of simultaneously where we've got everything in there that needs to be in there so that no one can say like, oh, well, sure. Yeah, you're looking at the relation of PTSD and functioning conditioned on pain. What about opiate use? You didn't account for that, so I don't trust your model here. Or you're looking at pain and functioning with drug use, but like you're not accounting for mental health stuff going on here, so I don't trust your model. We go through and just integrate everything in together. Makes it, make an argument that this is a more valid and appropriate model, and our estimates are going to be better with that. Does that help?
Yes, it does.
Okay, cool. Someone else had a hand.
I did, but I retract.
I retract.
I would draw my question. Okay, so we've gone through and factored out, we've restructured my model just with some basic kid algebra, gotten through and sort of put this in a position that is easier to see these conditional effects. Okay. So now we want to do, remember, anytime you're running any type of model, as soon as you hit an interaction effect, stomp on the brakes, stop, plot it out. We need to go through and see exactly what's happening. Like, I don't know, you may get to sort of like level 7 wizardry where you can just like eyeball an interaction term and tell me what that actually looks like in terms of the shape, but probably, I don't know, you'd have to probably spend more time on this than with you too. I mean, it's not something that I've achieved yet to be able to just eyeball an interaction term back. Oh, this is what this is looking at. What we go through and we do is we go through and plot this out. We go through and take a look at the effect of X on Y at different levels of our moderators. Okay, so what we're going to do, pretty easy. Spreadsheets are amazing for this, is we're going to substitute high and low values of our moderator and look at the effect on our base association. So looking at the simple slopes of pain and PTSD, what I'm going to do is I'm going to substitute high and low values of pain, holding everything else constant at 0, to look at the moderating effect of pain on the relation between PTSD and full functioning. Okay, so I'm going to take my model. Here's my model, this is just my factored model that I got from right here, right? So I've gone through, factored my model out, okay? So what I'm gonna look at is first my simple slopes, my simple slope for the association of PTSD and functioning at high levels of pain. So here's my model, okay? And what I'm gonna do is I'm interested in the relation of PTSD and pain. Everything else at high and low levels, or excuse me, PTSD and functioning at high and low levels of pain. Anything that's not involved in that, I'm just going to hold everything else constant at 0. right? So if I do that, if I hold opiate use constant at 0, plug zeros in for that, this is again, so the magical part of centering, as soon as I do this, these things just go away, right? Yeah, I'm multiplying something by 0. Those take off and are gone, okay? So I'm left here with my intercept, value of pain, and so my factored interaction term. What I'm gonna go through now is go through high levels of pain. Remember, we centered pain. Standard deviation is 1.34. High levels of pain, we're just going to call that a standard deviation above. Drop in values of 1.34 here. Each time we have pain, we're going to run this out. And we get an expected value of y is equal to negative 3.43 plus 0.04 times PTSD. 0.04, this is the simple slope of PTSD condition on high pain severity. See how we got that? Okay, same thing. So again, we're gonna start back up here. We're gonna jump ahead here because we already went through and we got rid of opiate use. So we're gonna we already done that. We don't need to start back at square one. We're gonna start here. This time we're gonna substitute in low levels of pain. So we've got here low levels of pain because we centered standard deviation below negative 1.34. Drop those in. Gives me my simple slope. I get about equation of 23.51 minus 0.42 for PTSD. This is my simple slope of PTSD condition on low levels of pain. Okay. Now I could put any value for high and low levels of my moderator. Convention says they're using a standard deviation above, standard deviation below. That's convention. We'll talk about strengths and weaknesses of that, but this is essentially how we would go through and sort of generally pick points to go through and look at the conditional effect of PTSD on functioning at high levels of pain, versus standard deviation above the mean, and low levels, standard deviation below. And what we see is we get different coefficients here, right? People see how we went through it and got this? Yeah, okay.
It's kind of related to the model overall.
Yeah.
Other than for like reasons of theory, is there a reason we didn't include like opioid use impact on like PTSD?
That's a good question. Hold on to that. We'll talk about that. Yep. Okay. So we're going to do the same thing for opiate use because we have this other second hypothesis about opiate use moderating the relation between pain and functioning here. Okay. So again, what we're going to do is we're going to go back through for no opiate use. We've got our whole equation here. This time, we're not interested in PTSD. So anything having to do with PTSD is not part of this this effect. Throw in a 0 for PTSD, all that goes away. Here we're left with a reduced equation, just including terms for opiate use and pain. No opiate use. We set in our centered model that we've been working with is equal to a value of negative 0.5. We drop that in and we get our simple slope for the unique effect of pain on outcome for people who are not using opiates. And then go through same thing for opiate use. Start right here, values of 0.5. And again, I cannot emphasize this. Opiate use is a dichotomous variable, but we have equal splits. If we take equal splits and we subtract the mean of opiates, we're going to get people who are using at 0.5, people who are not using negative 0.5. Do not assume that this will happen with your dichotomous variables. You have to actually go through, subtract the mean. It would probably give you different values for people who are using or who are not using. The difference will always be 1, but you'll need to make sure that you're plugging in the appropriate values for use and not use, or group 1 versus group 2, things along those lines. Okay, and so now we get a separate equation here looking at the conditional effect of pain on role functioning for people who are not using opiates. People following the logic in terms of how we're basically just using math to sort of bend this model to our will to go through and look at the specific things that are of interest to us. Okay, now for this one, can we throw in whatever value we want to look at the unique effect of pain on outcome across opiate use? Not really. We only have 2 points. We only have 2 values that really mean anything because it's my moderator is a dichotomous, it's a 0-1 variable, right? With my continuous moderator, I could look at the effect of PTSD on functioning at a half a standard deviation above the mean, a full standard deviation, 2 standard deviations, 4 standard deviations. We start to get to a point where it probably doesn't make any sense to look at 4 standard deviations because I don't know who that actually corresponds to, right? Which is where that standard deviation above and below the mean makes some sense. So here, for the previous example, there's all sorts of different values in the moderator we could look at. Here, with a dichotomous moderator, we've only got 2 values that really make sense. So this makes it pretty easy. All right, so holding PTSD constant at the mean of 0 for this makes sense so long as PTSD doesn't moderate the interaction of opiate and pain, opiate use and pain, okay? Kate, this is what you're getting to. Do we need a three-way interaction here? If PTSD does change the nature of this interaction, now we've got a 3-way interaction. If we don't have that 3-way interaction in there, Lisa, to your point, we've got a misspecified model, right? So this starts to become an issue where now I've put this together just as a didactic to just kind of so you can see how this works around. When you're actually running these analyses, what you need to do is think about like, is there a reason to believe that the interaction of pain and opiate use would be different for people with high levels of PTSD and low levels of PTSD, okay? And if you think that's a possibility, then we should probably go through and include the 3-way interaction of PTSD, opiate use, and pain. And if we have that 3-way interaction, then we need the 2-way interaction between PTSD and opiate use in order to sort of make this a viable model, right? So the question is think about model specification and what I know about my area from stuff. What terms do I need to have? Not everything always has to be a full factorial design because then you have like 17 different interaction terms and none of them are going to turn out because we'll talk about these are very difficult to identify for a couple of different reasons. But this is a conceptual question for like, why would I go through it? Does it make sense to have these other things in here, right? You can default to full factorial models all the time, but then you're going to have a bunch of terms that are all sort of stacked on top of one another. Think about a good question is like, if I were to find that effect, would that be meaningful and could I make sense of it? If the answer is no, or the answer is there's no reason to even ask that question, then it probably doesn't need to be in there, right? So this is, I can't tell you whether or not this makes sense or not. This is a conceptual question, okay? Comfortable with that? So what we then do is once we have these set up, then we can go through and we can just look at our simple slopes, okay? And what we can do, Excel is a brilliant way to go through and plot this out. What we can do is we can just go through and say, here are my simple slopes for the relation of pain and functioning for people who are not using opiates and who are using opiates, okay? We see an expected value here. What I'm doing here is just plugging in high and low values of pain in this thing so that I get a point for, so for people, who are not using opiates, that's this dashed line here. So I throw in a value for low pain, get that point, throw in a value of high pain, get that point, and then SPSS just creates a little line for it, or Excel creates a line. Same thing for my equation for people who are using opiates. Throw in low pain, throw in high pain, gives me a line, gives me my simple slopes. Okay. Allison, looking at my simple slopes. So let's say that I do have evidence for an interaction of opiate use times pain, right? What am I seeing in terms of my simples? What are my simple slopes telling me?
Well, I'm looking at this, like, the slope is steeper for the no opioids. So
So what does that, you're exactly right. What does that steeper slope imply about the relation between pain and role functioning for people who are not using opiates?
Like a stronger relationship.
It's a stronger association. Or just like Daniela predicted way back at the beginning, and if I'm sort of part of the pharmaceutical company, I'm probably pretty jazzed about this, is saying for people who are using opiates, we're seeing less of an association between pain and role functioning for people who are using opiate medications versus those who are not. I will say that this is an actual reflection of what actually happens in these data. I think I've fooled around with this to make that work. In actual fact, opiate use does not help people as a long-term solution to chronic pain. It's quite bad. But in the sense of having an example that makes some sense for this thing, we're saying, okay, maybe we interpret this as the medication is doing what it's supposed to be doing. Allison, what is the relation between pain and functioning for both groups?
It's a negative slope.
Yeah. Right.
So
So irrespective, as pain increases, my functioning decreases. It's just that association is a little bit tighter for people not using medications versus those who are. Right? Do people see what's going on with this? Okay, so probably when we go through and test this, we'll probably see that we have evidence for a negative relation, irrespective of opiate use. People who are and people who aren't still are having a negative association between pain severity and opiate use. It's just the magnitude of that effect is stronger for people who are not using medications relative to those who are. Okay, people, and this is sort of again why I badger you all about like, what does this mean? What are the implications? Things along those lines. Very important. Saying we have a stronger association for people who are not using versus those who are using medications, suggesting possibly that medications, at least in this example, may have beneficial effects because it's starting to decouple some things. So pulling this together into a meaningful interpretation. Okay. What about Jalen, what's going on this second simple slope graph here? So here we're looking at the interaction of PTSD and pain. Different type of effect. What's happening here?
Just to double check, sorry, our y-axis is still like the role function.
Yeah, why actually it's
Okay.
still really functioning.
We're seeing a really correct me if I'm wrong. In the high pain, we're not seeing like a super big difference between like the PTSD levels and then in the low pain condition, we're seeing like, I don't know, I would say like a decent size effect of like the PTSD level, because people that have low PTSD and low pain seem to be like functioning quite a bit better than people that have high PTSD and low pain.
Okay, excellent. You're spot on. The one thing I would say with this, right, and so this is where I want you to divorce your mind from thinking about levels, right? Because remember what we're talking about is we're talking about change in an association. Now it's easy to go through and take a look at this and say like, oh, comparing like as if we were doing a group level comparison, but we're not. What we're doing with this is we're looking at the impact of pain severity on the association of PTSD and role functioning, right? So what you said was exactly correct, Jim. And the only thing that I would tweak on that is sort of framing that more in terms of associations as opposed to peak differences, right? So what we would say here is for people with low levels of pain, right? People who are accident survivors, low levels of pain, we see a fairly strong association between increasing PTSD and reductions in role functioning. As PTSD gets more severe, we're seeing people's functioning decrease, okay? But for people with high levels of pain, what's happening here, Kate?
Did you say that those who are experiencing
high levels of pain are like bottomed out or bottomed out on role functioning.
What we're saying is at high levels of pain, PTSD doesn't, at high levels of pain, PTSD doesn't look like it has really much of any association with role. I mean, you say, oh, that's a positive relation, that's a zero. I mean, it just like to error variance kind of tip that positive as opposed to negative. But for people with high levels of pain, PTSD doesn't matter. I'm just in miserable physical pain all the way, so my role functioning is bottomed out. It doesn't matter if I have high levels of PTSD or low levels of PTSD. If I have high levels of pain, at least as defined by this in this data set, functioning is just flatlined across the bottom. Okay. So what we're saying here is that yes, PTSD does have an impact and has an association with role functioning, but only for people with low levels of pain. People with high levels of pain, doesn't matter. I just kind of floored out and I'm not functioning at all. Right. PTSD is inconsequential to my level of functioning at high levels of chronic physical pain. Okay. People seeing how we're getting sort of this and sort of interpreting. And so again, the key here is to force yourself, you'll want to start talking about like, oh, sort of the difference here and the difference here. No, because these are arbitrary points. Like these have no actual real meaning. These just happen to correspond to a standard deviation above and standard deviation below. I've got one paper where I did sort of compare those because it started to become relevant. I had to do some trickery to go through. I had to play around with the model to go through and sort of get some stuff here. But generally what we're looking at is the continuous association between our predictor and our outcome at high and low levels, right? So we're saying evidence of negative relation there, no support for an association at high levels of pain. Yeah, Abby, did you have a question?
I withdraw my hand raised again.
Okay. No, tell me a question. Right, do people see where this is coming from and how this starts who's excited about this? Yeah, it's pretty freaking cool, right? You're saying like, we're starting to say like, okay, yeah, these things are related to one another, but like under what conditions? Like sort of where are they related? Where are they not related? Clinically, this kind of matters because like at the end of the day, if I got someone with horrible PTSD or excuse me, horrible pain, is PTSD the first thing I treat? Probably not. Probably need to get the pain under control because it doesn't matter if they're having intrusions, nightmares, things along those lines, because it doesn't matter in terms of their functioning because they're just kind of miserable. Yeah.
Okay, now I do
Okay.
have a question. So then what, like when we would talk about this kind of effect, like how would you talk about the fact that it like is a moderating variable, but only at a specific level?
Couple of different things there. With this continue, and we're going to talk about, people will refer to this as pick a point. This is standard in our field. Standard deviation above and below is just kind of how we go through and do things. But standard deviation above and below are completely arbitrary, right? And it doesn't tell me, so at some point here, PTSD stops being associated with functioning, but I don't know where that is, right? But that seems like something that could be an important thing or an interesting thing to know. We've got a different procedure to go through and do that. We're not going to focus on it here because we've got just getting this under control will be good enough. But an approach, Johnson-Neva plot sort of represents this a little bit differently and contains a whole lot more information. I think it's really cool. But this is what we'll see standard operating practice in psychological science. Okay. All right. Anything in sort of close inspection, anything weird or sort of odd or sort of nonsensical about these graphs? Yeah.
Seems centered around zero.
What's that?
Seems centered around zero and role function.
Yeah. Can I have negative values of role functioning? No. So technically what's going on, like we've got less than the bottom of role functioning here in terms of this here at high standard or my points or expected value of role functioning at high pain, both are below the floor of role functioning. And so wanting to sort of keep an eye on what's going on in our data, because remember that these are just predicted values. These aren't real values. These aren't values in the set, right? What my model is saying is based on these things, this is the value that I would expect for role functioning, even though that's below the floor of what role functioning actually is, right? That's fine. That doesn't invalidate our model. The sort of the conclusions are still the same, but we just want to be careful in terms of as we're putting together representations, being able to address what's happening with this stuff. Okay. All right, so plotting our simple slopes in Excel, pretty straightforward. What we just do is we create a 2x2 table of Y values, high and low value, high and low values of our predictor and our outcome. What we can do is just insert your regression equation and then just plug in your scores, go through and pull that up by selecting a line chart through your insert menu here. Things to do if you got negative values, right, to go through, because otherwise your axes will be all kind of screwed up and weird. So to problem solving that. If values on your horizontal axis don't represent your X values, sort of going through, just playing around in Excel to go through and get scores that make some sense. Okay, in Excel, this is what this is looking like. How I went through and grabbed this, so you can see I've got a 2x2, so I've got low pain, high pain, low PTSD, high PTSD, and then what I've just done is I've plugged in my equation. This is just my simple slopes equation. 23.59.042, right? And then I put in my value for low pain, same equation, high pain, same thing like that. You're just going through and getting these set up. The thing that you want to do always is going through and making sure once you do produce these, making sure that your simple slope plot represents the actual plot that you want, because sometimes it'll be the opposite direction. Just make sure that your x-axis reflects your conditional effect, and your sort of legend here has high and low levels of your moderator. You might have to go through and hit the switch axis so it turns things around so you get the right plot on there. But this is just plotting things out in Excel. Okay. Questions about this? Okay. So up to this point, what we've done is we've gone through, we built our multiplicative model in SPSS. We ran that, we got our coefficients, we got our p-values. Everything's from that point forward up to this point has just been stuff that we're doing, like manipulating our equations, sort of going through, plugging in high and low values. We've not needed SPSS to do anything up to this point, right? This is just the raw power of our brains doing this once we got our main regression equation, which is pretty cool, right? But as I go through and I factor this, and as I go through and plot this out, what I don't get is absolute values for the conditional effects at high and low values of my moderator, right? So if I have evidence of non-zero interactions, right, in SPSS, right? So I go through and I take a look at my coefficients for my interactions. They're associated with p-values less than 0.05, and so I say I have evidence for an interaction term. Cool, right? Well, what I don't have with the model that I've got up to this point is telling me the extent to which I have evidence of non-zero effects of X on Y at sort of like my chosen levels of my moderator. Okay. So for example, here, right, my simple slopes for the relation of PTSD and functioning at high and low levels of pain. If I go down through and I take a look at this, looks like I got a positive association there, right? Because as I go from low PTSD to high PTSD, I have incremental increases in my functioning, right? I don't know, it doesn't look like a lot, but maybe, like, am I saying that like at high levels of pain, like PTSD severity results in greater levels of functioning? I don't know. I can't rule it out by just eyeballing, because I don't know how many people are in the sample or sort of what the scaling is or anything like that, right? This also looks like it's a pretty substantial negative association, but there's nothing in the model or anything that we've done up to this point to test whether or not at a standard deviation above or sort of standard deviation below the mean of pain, whether or not PTSD holds, whether or not I have evidence of that PTSD does hold an association here, right? So I've gone through and I've done all this stuff, but I actually can't test this, right? All I have is a picture to look at and an interaction term with the low p-value that says, yeah, based on my model, the association of PTSD and role functioning looks like it depends at least to some degree on pain, right? What I need is some way to go through and get an inference test of these to see whether or not I have evidence for a slope at both of these. Okay, so again, we've done almost everything. We just don't have a p-value for these slopes. If I don't have a p-value or test for these slopes, it's going to be hard to go through and communicate to reviewers or my committee, like whether or not I have evidence for an actual effect here. Okay. So what we can do is we can go through and start tweaking our model to test these simple slopes in the multiplicative model, okay? And what we're gonna do is we're gonna start to change things around to look at simple slopes at high and low levels of my moderator. So again, my first question, what's the relation of pain severity and pain severity on neural functioning, relation between PTSD and neural function? I can't. Things that way. I don't know. What, someone tell me, like, on your what is this?
What is the impact of pain severity and the relationship
Between PTSD
and role
Okay,
function?
okay, so, all right, there we go. Thank you. Back here. So what we are wanting to do, we're gonna tackle, we've got two hypotheses. We're gonna tackle the one with my continuous moderator first, right? What's the impact of pain severity on the relation between PTSD and role functioning? All right. What I would strongly recommend is maybe not right now, but as you go back through and do this, just start mapping out and giving yourself instructions. These are the things that I need to do. These are the steps I'm taking to go through and do this, because this starts to you get turned around with this, okay? First thing I'm gonna do, if I'm gonna go through, because what I wanna do is I wanna test the association of pain and PTSD, or excuse me, the association of PTSD and neural functioning at low levels of pain. I wanna test the relation between PTSD and neural functioning at high levels of pain, okay? So what I'm gonna do is I'm gonna go through and run a couple of additional models. First thing I'm gonna do is I'm gonna rescale my moderator to create two new variables that correspond to high levels and low levels of my moderator, in this case, pain, okay? So what I'm gonna do in SPSS, I'm gonna create a variable called high pain. High pain is gonna be equal to pain minus a standard deviation. This is my centered variable, right? So I'm gonna take my centered variable, I'm gonna subtract a standard deviation. This is gonna produce my variable for high pain. So in this case, I'm gonna take pain, I'm gonna subtract 1.34, because I've got a standard deviation of 1.34, subtract a standard deviation. This is gonna give me my variable for high pain. Then I'm gonna create a variable for low pain. Low pain is gonna be pain minus negative standard deviation, which is gonna end up being pain plus a standard deviation to give me low levels of pain. Now I see frowns and furrowed brows because this is counterintuitive, okay? But if we talk about what's happening here, okay? So here's my centered pain variable, okay? And let's say case number 23 has a value of 0. Case number 23 has a value exactly at the mean, okay? What I'm gonna do then, so then we've got a standard deviation 2.3. So negative 2.3 is low levels, 2.3 is high levels. Okay. Let's say I go through and I calculate my high pain value, the new variable. New variable is pain minus 1. So my high pain variable is pain, centered pain minus a standard deviation. If I do that, if I take every variable in my set and I subtract a standard deviation from it, I get a new pain variable, my high pain variable, okay? My high pain variable now has a mean of negative 2.3 and a standard deviation of 2.3. My person who is at 0 now has a value of negative 2.3. Where is 0 at? 0 corresponds to a standard deviation above. I subtracted it seems like high pain, I should add a standard deviation. Nope, I subtract it, because if I subtract a standard deviation from everybody, now my new mean of that variable is negative 2.3. 0 corresponds to a standard deviation above. And in our regression model, what are we always modeling things at? 0. 0 now corresponds to a standard deviation above the mean in my high pain variable. Okay. Same thing for low pain. Low pain, I add a standard deviation, to everybody in the set, right? And now my mean value is 0.23. Case number 23, that was at 0 in my centered variable, now has a value of 2.3. Where's 0? 0 is now below the mean, right? And so this is counterintuitive. You'll mess this up too. But remember that for high pain, we always subtract a standard deviation. For low pain, for low moderator, we always add a standard deviation. And we're just playing around with that, where that 0 point is with this. It's counterintuitive, but if you kind of map it out, you'll see why this works. What we're always wanting to do is we're wanting to shift what 0 represents in our model, okay? So for my high pain model, I want 0 to correspond to a standard deviation of the mean. So I subtract a standard deviation from everybody. For my low pain model, I want a standard 0 to correspond to a standard deviation below. So I add a standard deviation to everybody, and we're just shifting things around here. All right. So what we've got in our data set, we've got 2 new variables. We've got a rescaled variable for high pain, a rescaled variable for low pain. What we're going to do then is we're just going to create 2 new interaction terms corresponding to those conditional values of my moderator. So I'm going to create a new interaction. Before I had PTSD and pain, now I'm going to create a new interaction variable that's high pain and PTSD and low pain times centered PTSD. So now I have 2 interaction variables, 2 more interaction variables in my set. One interaction corresponding to high pain, one interaction corresponding to low pain. Okay. And then what I'm going to do is I'm going to analyze a separate regression model containing those conditional values for my moderator. So I'm going to run 2 new models. One model is going to be looking at the association of X on Y, where everything's centered at high levels of pain, and another one that's going to be centered at low levels of pain, which is going to give me a test of those individual simple slopes. So I've got a couple models here. I've got my intercept, I've got coefficient for low pain, opiate use, PTSD, opiate use times low pain, and PTSD and low pain times PTSD. I basically took the same model and I just swapped out any point there was pain. I just swapped in low pain for it, and so it reran that model. Okay. Same thing. If I go through and I take a look at this, my value of PTSD here, this is the unique effect of PTSD in functioning at low levels of pain. If I go through and I run my second model, same thing. Here I'm just swapping out any time at any point in my original model where I had pain. I'm just substituting high pain or corresponding interactions. So now I have high pain, opiate use, PTSD, opiate use times high pain and PTSD. And now what my coefficient for PTSD is giving me is the unique effect of PTSD in functioning at high levels of pain. Okay. What's really cool is these coefficients that you should be getting in these models should be identical to the coefficients that you factored out on your own. If they're different outside of minor rounding variations, you've done something wrong. It's an excellent check to make sure that you've done this correctly. But now what I've got with this model is now I've actually gone through and have p-values for each one of these that correspond to these simple slopes. So what I've got is I've got a p-value for this association, I've got a p-value for this association, which I can now start to go through and start making interpretations from. Okay, so what we've got here, looking at our effects of centering on my models, and again, this is just a check here, right? So my centered solution and my uncentered solution in just my additive model. Here I'm just looking at regressing role functioning on pain, opiate use, and PTSD. Okay. If I go through and I take a look My model summary, my R squared, everything's the same, everything's identical. My coefficients are all identical. The only thing that changes is my constant, right? We talked about why that is. Essentially, here I'm looking at in both cases, my intercept is just looking at the expected value of functioning when everything else is held constant at 0, right? Here, everything held constant at 0 means no pain, no OP use, and no PTSD, decent high levels of functioning. Here, pain at the average, PTSD at the average, controlling for OP use, and now I have much lower levels of pain or lower expected levels of role functioning. But nothing else changes. My coefficients, my standardized coefficients don't change. My unstandardized coefficients don't change. My test statistics for my coefficient or for my predictors don't change. The only thing that changes is this constant. Okay. People on board with this? Now, if I go through and center multiplicative models, a bunch of things start to change. Okay. My centered solution, here's my model summary, right? My R squared, things like that. But if I look at my coefficients here, what I'm going to start to see is differences across these. My model summary, my R squared doesn't change at all. I just sort of move where the 0 value is. The overall test of my model doesn't change, it's identical. Okay. But if I go down through and I start looking at sort of these individual coefficients, I should see very specific types of change, right? So here, my constant changes, but I know my constant's going to change because the constant always changes around whether I center or not, right? But I'll also see that, remember, as we talked about, centering does not impact my higher order interactions or my highest order effects. Here I have two interaction effects, two-way interactions. And in my uncentered model and my centered model, these are identical, right? So my unstandardized coefficient, my standard errors, my t values, my p values, all of these are, all of this stuff is the same, okay? But if I look at my first order effects, now these do start to change depending on whether or not I have a centered solution or a non-centered solution. Now, all of a sudden, my unstandardized coefficients for pain, PTSD, and opiate use look very different than what we get here. Why is this? And my corresponding p-values and t-statistics, these are all different as well. Following the logic with this. With my standard first order effects, could the unique effect of X on Y change depending on what the other values were? No, can't change around. What I've done here is I've gone through now is I've thrown in terms that allows the unique effects of X on Y to change depending on other levels of my variables, right? Here, in my centered variable, in my centered solution, 0 corresponds to average levels of things across the board, right? So this is reflecting the unique effect of pain on functioning at average levels of PTSD holding opiate use constant. This is the unique effect of PTSD on role functioning at average levels of pain holding other things constant, right? But because here we have evidence, very clear evidence for an interaction of PTSD and pain, and we get a claim evidence for an interaction of opiate use and pain. Both of these interactions, because we're getting support for these interactions, this is saying that the effect of pain on role functioning is dependent on opiate use, and the effect of PTSD on role functioning is dependent on pain, right? So depending on what levels of pain or where I center this stuff up, it's going to start changing these effects up here. So now, in my centered and my uncentered solution, these are saying my first order effects correspond to very different sort of subsets of the population. Here, this is looking at the unique effect of pain, opiate use, and PTSD on role functioning at average levels or controlling across the board. My uncentered solution here, this is looking at the relation of pain and PTSD for people with no opiate, who are not using opiates, who have no PTSD or have 0 PTSD scores. This is looking at the relation of PTSD with role functioning for people with 0 pain scores who are not using opiates. This is the difference in opiate use and not opiate use for people with no pain and no PTSD. This is the difference in opiate use and not use for people at average levels of pain and average levels of PTSD. Okay. The thing to do is to wrap your head around what's going on here is that these first order effects now correspond to very different segments of my population. Zero matters, right? And so anytime you're looking at a regression coefficient, you're saying, you should be thinking to yourself, this is a unique effect of X on Y holding everything else constant at zero. And then ask yourself, what does everything else constant at zero mean? Does this mean the absence of whatever I'm measuring? Or does it mean at average levels? Or if I've gone at high levels and low levels, does it mean like holding things constant at high levels of pain or low levels of pain? Right, to go through and sort of think about what specifically these coefficients represent, okay? And if you can do this, and if you can get good at this, and this starts to become automatic, things like hierarchical linear modeling, things like SEMs, multi-level models and stuff like that start to become pretty clear and apparent really quickly because it's all doing the same thing. It's just looking at the unique effect of X on Y when everything else is held constant at zero. So if I want to go through and look at a specific group of folks, then I just make that group of folks zero, right? And now all of a sudden I'm getting very specific effects estimates for those individuals, okay? So what you should see as you're going through looking at centered and uncentered solutions, you should see that your first or your higher order effects don't change. Your first order effects will change. Overall model shouldn't change at all, but you will see differences in your collinearity diagnostics, right? Here, in my centered solution, things are looking pretty good. Here in my uncentered solution, things are looking pretty terrible, right? Historically, what's going on is you got high levels of collinearity between your interaction terms and your first order effects, which is one of the reasons, and Aiken and West will talk about this, is like go through and I center variables that sort of helps my collinearity stuff. More recent stuff with Hayes says it doesn't matter because your p-values don't matter, your t-values, like it doesn't change anything across these two, at least in terms of your higher order effects, which is right? So it does reduce your collinearity diagnostics will look really gross in an uncentered solution, but it doesn't really have any impact on your model within the context of OLS. Now, if you start to try and estimate this with a maximum likelihood estimator, this will crash your model. Like you get non-positive definite errors, things along those lines. So it's something to be aware of. Essentially, what's going on is the covariance between your component terms and your multiplicative terms are determined in part by the means of your individual predictors. If you center those, it goes through and will make it'll change that covariance so you don't get as it will make those terms less correlated with one another, and so you don't have to worry about the math. Just it works. It just doesn't have a huge impact on ROLS regression. Okay. So again, if I go through and I took a look at the impact of centering on my correlations, all right, here we see my first order effects doesn't have any impact of my correlation on my first order effects, but all my correlations with my interaction terms change a whole lot, right? You can see for my centered correlations with my interaction terms are much lower. For my uncentered terms, we got correlations like the correlation of opiate use and pain is 0.946. I think it's huge, right? So centering goes through and fixes the collinearity issue. Now, the collinearity issue isn't an issue within these models in an OLS regression, but it is for other stuff. So just being aware what happens with this. Okay. When I go through and I take a look at my simple slopes, okay, in my full model, okay, as I'm going through and I'm looking, this is my full model with my interaction. This is the model that we originally factored out. Okay, this is the first model that my overall model that I look at. So here we have effect of pain and an effect of PTSD, right? But then we go down through and we take a look at our interaction terms, and it looks like I do have evidence for interaction of opiate use and pain, and opiate use, and pain and PTSD, which tells me that these first order effects here are not main effects, they're conditional effects. The effect of PTSD pain on role functioning depends on opiate use and PTSD. Effect of opiate use on role functioning depends on pain. Effect of PTSD on role functioning depends on pain, right? Just the way we've gone through and done this. And so in this situation, first thing I should be doing is plotting out these effects here. Okay. Now, if I go down through and I take a look at my my simple slopes, here's my model looking at the simple slope of PTSD on outcome at low levels of pain. Okay, so you'll see I've got low pain, opiate use, PTSD, low pain and PTSD, low opiate or low pain and opiate use. Okay, we're seeing that my higher order effects are unchanged, right? My higher order interactions don't change at all. My value for pain doesn't change at all, but all these other things do. Opiate use changes because opiate use is dependent on pain. PTSD changes because PTSD is dependent on pain. My constant changes because my constant always changes because I'm moving things around, right? Well, what I've got here is here's my test for the unique effect of PTSD on role functioning at low levels of pain. And if I look at this, I get a very small p-value, right? Saying that, yeah, for at low levels of pain, PTSD has a very clear negative association with role functioning at low levels of pain. If I go to my high pain table, again, higher order effects don't change. But my sort of coefficient for pain doesn't change. But my constant changes because my constant always changes. My coefficient for opiate use changes because opiate use is dependent on pain here. And my PTSD coefficient changes because PTSD is dependent on pain here. This is the coefficient, the unique association of PTSD with role functioning at high levels of pain, right? So I've got high pain, opiate use, PTSD, high pain times PTSD, high pain times opiate use. And here, remember this was that situation where we had what looked like a slight positive association. We're going to look at the p-value. There's actually no unique effect. PTSD does not hold a unique association with role functioning at high when holding things constant at high levels of pain. Okay, this is a critically important slide. Okay, as you're going through and running these models, if you're not seeing this identical pattern of things going on here, something's gone wrong. Okay, like this is all about sort of checking your work to say, hey, are things turning out the way they should? If we start seeing these interaction terms change around, something's gone wrong because those interaction terms shouldn't change. If you start seeing your value of your moderator change, something's gone wrong because that shouldn't change at all, right? If you're seeing R-squared values change, something's gone wrong because those shouldn't change. This other stuff, that very much shouldn't change, okay? Anything that is dependent on, now if I had, let's say, negative affect, and negative affect wasn't associated, wasn't in an interaction with anything, then that shouldn't change because a negative affect can't be dependent on anything else. So that's going to be the same across things, right? But anything that's involved in an interaction that's not the moderator that you're specifically looking at, those coefficients are going to change around, okay? So mark this slide, and as you're starting to go through and do this, if your results aren't falling into this pattern, something's gone wrong. You've messed something up. You need to go back through and check that. Okay. Other thing too, you'll notice that I'm hashed out the standardized coefficients for your interaction terms. You have to do something special with those to get those. These aren't proper. These aren't sort of interpretable. SPSS doesn't calculate those correctly. I don't think STATA does either. So ignore those for right now. That's why those are crossed out. Okay. What we will do is here we're going to jump into the actual example in SPSS. And so we'll go through, walk through how we actually produce this next class. Okay. But want to go through and touch base, I guess, quickly with the last bit of time that we have left, talking about our standardized solution. So remember on that output, standardized coefficients for your interaction terms, I had those all crossed out and said, hey, don't look at those, don't report those. Standardized coefficients in SPSS. What's going on? And we had talked about this before. Your standardized coefficients all SPSS is doing is it's taking just the z-scores of all the variables in your model, your variables and all your x variables, just taking all your variables, changing them to z-scores, right? So you've got a mean of 0, standard deviation of 1, and then it takes all those z-scores, and then it just runs a model where you've got the z of y regressed onto the z of everything else that you've got in there. Okay, this is how SPSS is producing your standardized coefficients. And if you want to, and this is fun to just play around with this demonstration in the problem set you got. Don't report this, but for some model that you run, go through and change everything that your y's to z scores and all your x's to z scores, and just run the model with just the z scores. What you find is this unstandardized coefficients in the z-score model are equal to your standardized coefficients that you get from the model that you ran before, right? That's all that's going on. I mean, SPSS isn't in your data set, it's not creating them there and sort of storing them there, but it's doing it in the background, okay? Now, the issue is when we get into our multiplicative terms, we get into an algebra situation, because what state at SPSS, what these programs are doing is what they're doing is it's taking the multiplicative term that you created, it's creating a z-score based on your interaction term. The problem is mathematically, what we need to do in order for those to be meaningful is to be able to decompose those. We need to be able to take those interaction terms and be able to factor them out. Okay. The problem is that the z-score, or sort of the interaction of, if I took created an interaction term that's the z-score of opiate use and the z-score of pain, and I multiply those two things together, that's not the same. There's sort of this is not the same thing as the z-score of opiate use times pain. Same thing. The z-score of my pain by PTSD interaction is not the same thing as the z-score of pain times the z-score of opiate use. And so what we're doing, what SPSS is doing, is it's just taking the z-score of everything and then regressing that onto that. Problem is I can't go through and factor that z-score out into its underlying components, right? So in order to go through and actually get appropriate standardized coefficients for your interaction terms, we actually need to do a little bit of lifting on our own. We actually have to do it ourselves, right? So what we would need to do is we would need to go through and create z-scores for our y's and z-scores for our x's, and then take the z-score for our predictor and multiply it by the z-score for our other predictor to create an interaction term that's composed of my z-scores, and then rerun my model with that. With that, now I can go through and factor out these things like I had before, and then that all makes sense, right? So what I would then need to do with this is, if I go through same thing as before, right? If I go through and I create calculate z-scores for my y, z-score for my predictors, and then count z-score, and then create z-score interaction terms, and then rerun my model, everything's going to be identical except for the actual coefficient that I get in my z-score model. It's going to be my unstandardized coefficient. That's the z for my interaction terms. That's the coefficient. It's the appropriate standardized coefficient that I should be reporting for my interaction terms, as opposed to the one that SPSS gives me. Yeah.
Why not just do that from the start?
What's that?
Why not just do that from the start?
You could do that. The issue is, from an interpretive standpoint, is now you're interpreting things in terms of z-scores. Now everything are in terms of z-scores and standardized units. Which case, like, you could perfectly do in your analytics section, if you just said sort of models are presented as a standardized model across the board. There's really no problem with doing that. What you're missing is your unstandardized effects, which is typically what we report. But if you're fine with not reporting standardized effects because your scales are arbitrary and actually don't correspond to sort of real things, because they're all sort of self-report things, you could certainly do that. Okay. But what I would say, so for all these boxes where things are blocked out, what I would do is these coefficients, oops, that's in the wrong place. That should be right there. Not blocking out t-values. Sorry about that. That should be my, Matt, can you email me to fix this slide? This is an important slide with the big arrow on it. So move this over, okay? But here, what we would see in this output, these standardized coefficients actually aren't correct. Because what these are is these are represent the z-scores of my multiplicative terms. I can't pull those apart. What I would need to do is change everything to z-scores, create new component interaction terms with the two z-scores, then run this model. And then whatever my unstandardized coefficients were for these interaction terms, those are going to represent the standardized coefficients that I should report in a model, okay?
I have a question on
Yeah.
this slide. You said we have an error. So do we switch like the values and flip them on the other?
Well,
Like the 0.112, does that go into the T area?
yeah, so yeah, this thing that I
Oh,
boxed
the
out.
numbers are just
Yeah, no, the numbers aren't funny. It's just,
Just
here I boxed out,
should be on.
the box should be on this, yeah.
Thank you.
Similar to what we've got down here, okay? So
Yeah.
this is what's gonna happen, right? If I go through and I run my standardized solution, right, where I regress my z-scores on everything else, what you'll see is the unstandardized coefficients for your z-score solution are identical to these. Until you get down to these will be slightly different, okay? Now, this is the thing. Probably no one's ever gonna notice unless I review your paper and make this is technically correct. The thing is, it's science, we should probably do it right as opposed to wrong, just because no one will notice probably isn't a good reason not to do things the right way. So, and also look like a boss if you're like, hey, so what I did is I did this right, so to go through it, but then reviewers know not to flex on you because you obviously know your reasons, so. Just make sure to take note of that, okay, all right. We are in a really good place, made great progress today. This is all, this is a lot to try and go through and keep sort of, set up in your head. Again, you're going through, I know you're working on, your first regression set, but, as we're working through this and maybe before we come through and start working on the actual SPSS example, sometime between Monday until we come in. If you go through on that screencast channel, there's examples of the problem that we're going to go through, like looking ahead, start writing down some of these steps and start to help sort of consolidate this. This is a tricky thing. People have problems. There's just a lot of steps and a lot of things you gotta keep in mind all at once. So if you get a head start on this, it will for sure make things easier as you're following along and stuff. Okay. Awesome. All right. Thanks, everybody. You're all champions. Have a good night. Stay warm. Don't freeze to death. And let me know if you're in your snacks on this next Saturday.
You working tonight?
Maybe here on Friday. I'm like, will you be here on Saturday?